Now, here we have a question. The position of a projection fired at an initial velocity v sub 0 feet per second and at an angle theta to the horizontal at the end of t seconds is given by the parametric equations. Here we have x equals v sub 0 cosine theta t, and here velocity v sub 0 is 4. And y equals v sub 0 sine theta t minus 16t squared. Suppose the initial velocity is 4. That means here can be replaced by 4. So is this place. 4 feet per second. We want to obtain the rectangular equation of the trajectory and identify the curve. To eliminate parameter t, we shall get relationship between x and y. That will be the rectangular equation. So we have x equals v sub 0 cosine theta t. That's the one right here. And v sub 0 is velocity, initial velocity, 4 feet per second. Now, everywhere divided by the coefficient of t, which is v sub 0 cosine t. Then left-hand side is x over 4 cosine theta, because again v sub 0 is 4. So 4 here, cosine theta. Right-hand side, you got v sub 0 cosine t cancelled. So right-hand side is just t stands alone. When t comes out, we then replace this t and this t, t here, with x over 4 cosine theta. So that will give us here, we shall have a negative 16, this one, I put right here, t squared will be x over 4 cosine theta, and then squared, plus, again, v sub 0 is 4 times sine theta, and then times t, which is x over 4 cosine theta, this one. We may do some consolations. 4 squared downstairs is 16, so they may cancel those two 16th. We have a negative. X squared is here. Cosine theta squared is down on denominator. So that's the answer for the first term. The second term, you have a 4 cancelled. Sine theta over cosine theta is tangent theta, and then times x. We can see here the x with exponent 2, and here exponent for x is 1. For the different value of theta, theta is the angle. When angle is different, we may then have a different coefficient. So basically here we can see this is the equation of a parabola. If we give different value for different, if we give theta different values, we'll get different coefficient. So then this one would be our choice. What does it really mean if we choose this one? Let's put in the decimal. Here in decimal, I have given this theta pi over 3, this value. You see, pi over 3, pi over 3. You may give different values if you want. Pi over 3 is 60 degrees. That's the degree between the x-axis and the initial velocity, somewhere here. Okay, so we have different values for here. Let's choose 60 degrees or pi over 3 radians here. Then this will be the parametric equation. And then you can see instead of t here, I put b. So t stands for different time, or b stands for a different time, when theta is again 60 degrees or pi over 3 radian. You may play around with different time. B stands for time. So you can do that, you see. When B is 0.19 seconds, the object flying from here up to this place. Keep going. Okay, so you can see that. And see, it slides. Okay, so basically if t choose the different time, it's 0.09 seconds. It reaches almost the highest point you see about here. All right, that's the meaning for this question in physics. Okay, I'll see you next time.